Welcome back, everybody. Picking up where we left off the last time with the upper steering shaft from X231's dash. And what I did was also bring out the lower steering shaft. So we have everything here that goes from steering wheel all the way on down to steering gear at the front bolster. So this was the segment up here, all right, from there up that we were looking at the last time. This is that oddball universal joint that we have to try to see if we can save today. Otherwise, the rest of them, the other two, were just the standard ZB style, and I went to the parts store this morning, and it looks like this SKF UJ861 will be the appropriate replacement for the original universal joints, at least the serviceable ones. So our task today now is to see if we can disassemble this one that was never meant to be disassembled and save it. So getting back to just the portion that we were looking at the last time, I cleaned both of these yokes up with the wire wheel to get a better look at things and determined this yoke portion was just like this one when things started out, but they had to modify it because I can see about half of the old weld seam left at the bottom, just like the weld seam here that separates the yoke halves from the collar. So of course they had to cut the collar off of this one because they needed that real estate for the support bushing. And there's a groove right here where it looks like they started their initial cutting and then decided, let's move down a little bit and go right through the middle of that seam. I'm pretty sure that's what that old mark right there is from. So to take this apart, I think it's best to kind of replicate what they did right here. I think we'll start with this one. I'll remove the roll pin and get this short shaft out of here, and then I will do the same thing. I'll cut clear through that weld, and I'll remove the collar from these yoke halves. At that point, it's easy just to make one slit right here, and then another slit on the other side. These two yoke halves will come off the cross, and I can at least get some dimensions off that cross. The easy way to take this apart would just be to go straight for cutting the cross, but I want to keep as much of that intact as I can to know what I'm working with. It gives us a good reference point for starting out. So that's what I'm going to do. We'll get that roll pin out. Okay. I think the plan has already changed. Now that I have the shaft out of there and I can get a good look at the inside of the collar, it's solid all the way down through. I expected to see like a gap where the collar would end, but then the yoke halves would begin. And now I can tell by looking at it, the top of the collar was actually just stepped so that each yoke half sat down onto a shoulder. So these really aren't that thick at the bottoms. So now I kind of want to put it back on the shaft again so that I can vise it into the milling machine and start milling some of the weld out between the halves. So, okay, back to the other bench again. Anything that is worth doing is worth undoing. All right, I carefully milled away the center weld bead between the two yoke halves on each side. And what I'm going to do now is take a cutoff wheel and just start going along the weld seam on just the one yoke half. I decided that I don't want to actually cut this part of the collar completely off now that I know that it goes the rest of the way up to the end of the shaft. So I'll cut in just as deep as I think I need to be, just on the one half, and then we'll see if we can detach that and get it off of the cross. All right. Actually, that came off pretty good. This is quite interesting. No needle bearings. And I expected to find bushings. No bushings either. It's like it's just a metal on metal. So this peg is actually tapered. It gets smaller in diameter out toward the end. And the hole that's in the yoke half is tapered as well. So they sort of match one another. The trouble though is they're worn so loose. There's so much clearance. I've never seen a universal joint like this. I expected to find bushings in here, to be honest. Okay, we know now how to take it apart though. All right, everybody, it's the following morning and I haven't made any more progress on the U-joint project, but due to having to juggle unpredictable early springtime weather, I think it's going to be the best use of my time if I transition to some outdoor work and get a few items ticked off the list while it's still good enough to be out here. They're predicting some wet, heavy snow moving in tonight and lasting throughout the next week. So I guess now is the time to make some hay while the sun is shining. So I've spent the last hour or so setting the pot blaster up. I want to do some sandblasting. I got my redneck catch tarp here to keep recycling the sand, but I think the sandblaster is going to be the best way to clean everything on the inside of X231's dash here. And this won't fit in my cabinet, so I have to use the outdoor blaster. We're just above freezing. I think we'll manage all right without freeze-ups, but as long as you have all this stuff out and set up, you might as well do a few other pieces too, or at least have a few ready that could use a fresh cleaning. So that's the plan for this morning.
On cooler days like today, fog ups are going to be what I fight the most. Not getting an awesome mix of air and sand today due to the temperature, but we got it all done.
Okay, I've got the mess cleaned up outside. There's the drawbar brackets. Here's the dash, much improved. And I was able to do the belt pulley today as well. We'll cover the belt pulley in a later episode, but I think this was a detour worth taking this morning, because if I was still waiting on weather to clean the dash, it wouldn't have mattered if I had all the rest of the inside pieces done. We still wouldn't have been putting anything together. So good to have that out of the way. And I went ahead and blasted these brackets. They had the same ugly green primer on them as the engine, but because we're not using that primer anymore, and also because I should probably address the wear that is on both of these pins, it was best to just start over. So back to our U-joint project again. I spent last night thinking about how best to attack this yoke. I can't take it apart like I did with the other one because they've welded this inside clear to oblivion, trying to attach that to the end of this shaft. And I'm not gonna lie, I'm tired. I'm approaching another psychotic break point with this project. It's been too many impossible roadblocks. I'm to the point where I start making some really questionable decisions unless I really take my time and think about it. So I've decided I've got two options. I can either sacrifice the old cross here to try to carefully mill enough weld away to get this yoke off the shaft, or now that I see how this is put together, I'm tempted to try to save the original cross as well. So in that case, we still have to sacrifice something. And I think what I'm going to do is just cut the shaft right at the base of the yoke here, and I'll be sacrificing about 3/8 of an inch off the end of the shaft. And looking at the archive photos of X231, the way the steering wheel sticks up above everything else, so high, I don't think a 3/8 of an inch drop is going to be a noticeable thing at all. I'm unsure whether or not I'll be able to do any machining on the old cross because it's rather hard material. Where it's shiny here off my thumbnail, I was able to cut it with a file, but just barely. It's really, really hard. So plan A is to try to recondition and save the old cross. But if that doesn't work, I have a plan B. The new crosses from the new U-joints are the same overall width, you could say, from the end of the one peg to the end of the other peg. So these new crosses would fit between these caps if I was able to make the caps fit the pegs. All right. So lots of question marks, but first order of business, we need to get this cut off the shaft. Now we cut it in half. So I've been trying to mill the weld out of the inside of the yoke so that I could dislodge what's left of the end of the shaft from the hub. And some success. I think what we have is some heat hardening going on with some of the weld, because every now and then I'll hit a spot where the end mill just doesn't want to do it. So we might end up finishing that out with the Dremel, but we'll keep attacking. Okay, let's see if we've taken enough weld out to loosen the rest of the shaft. Looks like we did. There. Still have a good partial bore in there to utilize. There, we got it. Well, that completes the disassembly of the old U-joint. We could call this phase 1 complete. So phase 2 is going to be determining if I'm able to machine this old cross. In order to save it, I need to cut the taper out of the pegs. And as I said earlier, this is rather hard material. So first I need to fit it into the lathe, see if I can drive it and center it. Then we see if we can actually cut it. I am glad we sandblasted yesterday. Now, getting back to the setup to try to machine the old cross. Fortunately, every peg has a centering dimple in it. That helps us immensely for setting this up. So I threw the 4-jaw chuck on the little south bend here, and it's a number 3 Morse taper inside the spindle, so I put a dead center in there. That's just a slug that has a point on the end of it. You can see it right in the middle. And that point will align with one of these dimples. So that's what centers our cross in the chuck. Now for the tailstock end, this is number 2 Morse taper, and I had this really chewed up and worn dead center that I blunted the tip off of a little bit so that it better fits the shallow center dimple on the other end of the cross. So that's how we're going to get it set up on axis in our lathe. Now it doesn't matter which one we start with, so we'll just pick a peg and line it up on the center, run the tailstock up, line our center up on this other end, cinch it in a little bit. That's good. Lock it down. Now I've ran all 4 of the chuck jaws equally down onto the cross, and we're not so much cinching it as we are just driving it, similar to a basic faceplate with a drive dog, only each jaw acts like a drive dog. So that should be an accurate center. It should be a sufficient way to drive it. Now we just see if the cutter can do anything with it or if it's just too hard. I know the peg looks like it has run out to it, like a wobble. That's just the uneven wear that's on it. Yeah, it's hard. I can feel it. Seems like it is cutting it though. I'm just going very easy with it. Okay, I've determined that it is only surface hardened. You can hear that thump that's in it, and now we work out, and look at that, it cuts really nice and smooth. Okay, I'm going to do a back cut on the way back out. The bit insert is not loving life. I've already flipped it once, but I've just about got the hardening cut out of this peg. We're just about out. Okay, we're right there. Turn it off and you'll be able to see it better. So, okay. Where it's shinier right off the end of my finger and it's a little bit duller in here toward the root, that's what's left of the surface hardening. Where it turns duller in here deep, that's just mild steel. So, all right, that makes sense. So knowing what I know now, and see we've got quite a bit of hardening left over here, probably a good 2/3 of that one, but we're just about through it. So knowing what I know now, I'll finish just cutting this peg out with the insert. But I think the other 3, I might even take over to the bench grinder and just rough grind a lot of that hard stuff right off before I even put it back in the lathe. It'd just be so much easier on bits in the lathe, and these bits aren't cheap, even though I'm just using tiny ones. So that's the plan. We'll keep attacking. Just making the final cleanup pass now. Get down to our root right there. We've got a good rounded profile edge on the bit. Do a slow back cut the rest of the way out. We're basically all down to, all soft metal now. That's what I'm trying to say. So a little bit of hardness right at the very end because it's face hardened on that end as well. There we are. We made it through. So what I'm going to do, diameter check, I'm shooting for 0.525. Good. Hit the target right on. So we can take it out. There we are. So there's our difference. Nice straight peg as opposed to the old tapers. And this is the same diameter as the cross pegs in the new U-joints. So yeah, I think what I'm going to do, like I said, take some of that hard facing off the other three real quick with the grinder before we move on. And back in the lathe once again, the setup is the same as last time, and pre-grinding some of that hard material off of the pegs really made a difference. It's cutting a lot better. I know the cutter's doing a lot better. We'll all be experts by the time we're finished, so I'm just going to keep going here. I'll finish this one out to the same 0.525 diameter. Yeah, look at that nice chip rolling off. We're pretty much through the hard stuff into the mild steel, so life is good. And then we'll reset, finish off the remaining two. I'll bring you back when I'm finished here. Well, everybody, this late season winter storm has really been balling up my plans for this episode. The deliveries of materials that were supposed to be in yesterday to continue on with the U-joint project were delayed. I'm hoping they show up today. So in the meantime, I guess I need to find something different to do. I can show you the finished cross. I'm happy with the machining. We really made all four of those pegs nice. They're uniform, they're straight shanked, got the taper out of them. So my plan now is to try to create some sleeve bushings to go on each one of the pegs. So we're using bushings as bearings now in the new setup. If we are able to machine the tapers out of the yoke caps. It remains to be seen how hard this material is now. So the materials I mentioned that I'm waiting on is the bushing material to make the new bearings and a special cutter to see if we can now true out and size all four of the yoke caps. So we may still fail at this endeavor yet, but we're as far as we can get on it until a delivery truck shows up. So because we're in the home stretch on X231 for the season, we just have probably a few episodes left. Let's keep attacking. Some progress is better than no progress. I want to show you all something interesting I noticed about the dash after I finished sandblasting it the other day. For some reason, my eye was never drawn to this detail until I sandblasted all of the rust and remaining splotchy paint off of this piece, and then I caught it. They built the dash with about an inch of rear-facing rake to it. Tight at the top at the square, about an inch at the bottom. I don't know why. I never noticed that until I got it all cleaned up. So they were really trying for some styling with this piece. The more I look at it, the more I like it. And I mentioned how it would be easier to count how many different pieces went into its construction after we got it cleaned up. So we have the main surround here. That's piece number 1. And then up toward the top, it starts getting a little bit crazy. So here are the weld lines. So that'd be piece number 2. And then they formed this radius up to right there. So that's piece number 3. Top plate is number 4. We have a separate rounded piece on the, we'll say the snout. That's 5. We have another corner piece here. That's number 6. Corner piece here, 7. Then our next radius, 8. And then finally, number 9 right there. And take into account the bump out for the hour meter. So we have the ring. That's piece number 10. And then the face of the ring, a little bit of weld, just evident right there. That'd be piece number 11, just to make up just the main body of the dashboard, or dash panel, sorry. Dash assembly. And then you have all the other collars and, you know, the little pivot for the starter lever. And then what I think is amusing is they crafted and sloped and angled and curved all of that. And then fuel tank bracket, we just threw a piece of angle on there and glued it. Why bolt it when you can jolt it? It's like, we spent enough time on this. Get a bracket on there. Zap, zap. Bracket done. But Yeah, I love this piece. And as long as plans have changed, it turns out we'll get to the belt pulley today after all. We won't have to save that for a later time. So when we found X231, it was just like this. We had the 10X belt drive housing in place. The flange, of course, is a part of the housing, but there was nothing at all on it. And we know X231 had a belt pulley on it originally because this archive photo from the rear, we can zoom in and clearly see there was a pulley mounted on that drive. This pulley now we sourced from a swap meet. This is a production 445 steel pulley, just like the one pictured in the archive photo. Casting number 10A7098 on that spoke. We have a rather robust balance weight in place, but for all intents and purposes, if this is not identical to the dimensions of X231's original steel pulley, it is certainly close enough to bolt up and work just fine. Now, I know you all are going to ask for good Rockfords, ready to go for it. Now, on a steel belt pulley, I've always considered the outer face to be the one where you can either read the casting number or the balance weight is located. But the hub and the spokes are not centered inside the pulley. They're actually offset a bit. So if I installed it the way I would consider it to be correct, we're very close to this square boss on the axle housing. That's like for fender bracket mounting. And looking at the archive photo, you can tell the original pulley was not that close to it. So if I flip this around and we position the offset the other way, there we are. Now this inside edge looks just like the archive photo, being so close to the machined edge of the rear case. And just one more view of that archive photo just to compare. Yeah, I think this is the right way to do it. So I put the bolts in and tightened them down, and yes, it looks good. It will fit, it will work, but I need to show you all the clearances that we're dealing with here. This is rather astounding. So in here, now, the head of the bolt that's off the end of my finger, down on the inside, watch how close the balance weight comes to it. Here's the weight coming around and, ooh, danger close. If they would have put any larger of a weight on there, I don't think we would be doing this right now. It doesn't hit, but if I put paint on both of those surfaces, I think we're going to have contact. It is that close. And all the other flange bolts are the same way, but there's where our weight is. We'll roll it around. It doesn't, that's just gear teeth you hear inside. It doesn't clash. It doesn't bind. There's our balance weight again. And sorry about that. Wow. Is there even light between those two pieces? I don't know. But hey, it fits. It spins. For X231, it will work. I just wanted you all to see that. Well, everybody, I hate to say it, but looking at how many files we do have on the camera already, I think I'm going to call it cut and run right here. I apologize for the rather choppy workflow in this episode, but I think we did pretty good at making the most out of the time and the weather conditions that we've had these last few days as far as laying groundwork and just trying to get things done. So apologize for still no resolution on whether or not we will be able to service the non-serviceable U-joint, but I think for the rest of this evening I'm going to decide how to jig these loose yokes up in the milling machine to true out the insides, and hopefully tomorrow a delivery truck shows up. If not, I've got a whole bench full of other pieces that we can start going through that have to go back into that dash anyhow. So one way or another, we'll still get work done. So I thank you all for watching. I hope you enjoyed this episode, and I hope to see you back next time. Almost made it all the way through without my phone going off.